Time with a new topic for class 11 students, that's called optical isomerisms. I am teaching this particular topics keeping in mind that you do not know anything regarding the optical isomers. Just you pass out class 10, you are learning optical isomers for the first time. Hope you will understand the topic. In case of optical isomerism, we should know different terms and their examples. Like we should know chiral carbon, we should know chiral molecule, we should know optical active molecule, optical isomers, and number of optical isomers, enantiomers, diastereoisomers, and meso compound. These are the things we should need to cover. First, let me discuss what is called chiral carbon. What is called chiral carbon? What is chiral carbon? Suppose there is a carbon and it is attached to 4 different groups. Suppose A, B, D, E. A carbon, this carbon is obviously is sp3 hybridized carbon. This is sp3 hybridized carbon and attached to 4 different atoms or group of atoms. What is chiral carbon? A sp3 hybridized carbon attached to 4 different atoms or group of atoms is called a chiral carbon. Chiral carbon, or it is called asymmetric carbon. Asymmetric carbon. sp3 hybridized carbon attached to 4 different atoms or group of atoms is called a chiral carbon or asymmetric carbon. Here A, B, D, E can be single atoms or can be group of atoms. For example, if I consider a molecule like that, hydrogen, chlorine, bromine and iodine, they are single atoms. All atoms are different. It is hydrogen, it is chlorine, it is bromine, it is iodine. Then this carbon I call the chiral carbon. This chiral carbon is indicated by this star sign. This carbon attached to 4 atoms, hydrogen, chlorine, bromine, iodine. This carbon is chiral. Here all are atoms, single atoms. Even we may have like this carbon, this is CH3, this is OH, this is hydrogen, this can be your NH2. Now we need to see as a group of atoms. We need to consider as a group of atoms. This is CH3 and here is OH, here is H, here is NH2, group of atoms. This is single atoms, but these are group of atoms. All are different. This carbon is also chiral carbon. Clear? Either they can be single atoms, A, B, D, E can be single atoms, or they can be group of atoms. As a whole, we need to consider CH3, OH, H, NH2. This is called chiral carbon. Clear? Yes. One more example, if I give like this. If I ask how many chiral carbon exist, if a structure is given like that, then a question is asked how many chiral carbon exist. This structure is called what? Bond line representation. Bond line representation, where carbon and hydrogen is not mentioned. Therefore, what you need to do here, you need to put one more hydrogen is there. Why? We know carbon has a tetracovalency. Therefore, this carbon attached to one chlorine, another carbon, and this hydrogen. Similarly, here also there will be hydrogen. Here there is CH3 group, here there is CH3 group. That you know. This is called bond line notation. Now, if I see this carbon, one is chlorine, another is CH3 group, another is hydrogen, and for this carbon, last, this is the group as a whole. If you consider for this carbon, one is chlorine, one is CH3, one is hydrogen, and rest whole the group. Now you can see all are different, chlorine, CH3, hydrogen, and whole the group. Therefore, this carbon is also chiral. Similarly, now we come to this next carbon. Next carbon. If I consider this carbon, one is hydrogen, another is CH3, another is bromine, and last one is this part as a whole. Therefore, this carbon is also chiral. This carbon is also chiral. Why this carbon is not chiral? Because this carbon attached to 3 hydrogen. This carbon attached to 3 hydrogen. That's why it is not chiral. This carbon also is not chiral because this carbon attached to 3 hydrogen. That's why not chiral. Therefore, here how many chiral carbon is there? 2 chiral carbon. This is one chiral carbon. That is another chiral carbon. One group, second group, third group, fourth group. Into check like that. Chiral carbon. Clear? Let me give one more example. Let me give one more example. Suppose this case. Suppose this case. Suppose this case. Suppose this case. If I ask how many chiral carbon is there, I need to check one by one. Obviously, this carbon is not chiral. Why this carbon is not chiral? Because this carbon is sp2 hybridized. This carbon is sp2 hybridized. All chiral carbon is sp3 hybridized. That's why this carbon is not chiral. Now come to this carbon. For this carbon, this is one group. This is another group. This is another group. And rest whole as a whole is a group. For this carbon, this group, this group, this group, this as a whole. Therefore, this carbon is chiral. Clear? This carbon is chiral. OH, H, CHO, and whole the group as a whole. Therefore, this carbon is attached to 4 different atoms, a group of atoms. That's why this carbon is chiral. Next, come to next carbon. For the next carbon, this is OH, this is H, this as a whole as a group, and this as a whole as a group. For this carbon, one is OH, one is H, one this group, another this group. All groups are different. Therefore, this also chiral carbon. Clear? Next, come to next group, next carbon. For the next carbon, this is the carbon. This is OH. This is H. This is another group. And this is as a whole as a group. Upper part. Whole upper part. I mean this part. This part as a whole as a group. Therefore, OH, H, this part and this part all are different. Therefore, this carbon is also chiral. Now, if we come to last carbon, this carbon is not chiral because these two are same groups, hydrogen, hydrogen. These two are same group, hydrogen, hydrogen. That's why this carbon is not chiral. Therefore, there are 3 chiral carbons. 1, 2, 3. Clear? Chiral carbon? Very good. This is how we need to identify the chiral carbon. Sure? Okay. Thank you.